What if I told you I could take you through all of Algebra 1 in 15 minutes? I could take you from the beginning of Algebra 1 all the way to the very end, and we could even play with Algebra 2 a little bit in this video. All in 15 minutes. My goal in this video is to take you through all of it. Please keep in mind that I do have a full course that you can take that breaks this down and of course goes through a traditional year, program. You could do that in 3 months though, but let me go ahead and take you through Algebra 1 in 15 minutes. My name is Amos Tarfa. I'm the director of the Learning Institute for Excellence and LifeSTEM Academy, and I've been teaching mathematics in one way or the other for over 15 years. Today, I'm excited to share with you the journey of algebra. Let us begin from the beginning. So, pre-algebra, of course, is a prerequisite for algebra, so you need to know your fractions, decimals, percents, ratios, and proportions. So that's what we're going to write right here. You need to know how to add fractions. The big thing with fractions, of course, is knowing that if they have an uncommon denominator, you need to have like denominators to add them together. So therefore, we start out with this. So basically we change that to make sure that the left side gets multiplied by 3 over 3, the right side gets multiplied by 2 over 2, and so we have 3 over 6 plus 2 over 6, and the rest is history. Okay, moving forward. So we're going to draw a line right here, and I'm going to move into the next phase. Again, pre-algebra, we have a free pre-algebra assessment to help you figure out any holes you have, any gaps you have in math, and then we can help you fill those gaps. Once your pre-algebra is solid, the next thing you need to do is to jump into equations. So we have one-step equations like x plus 5 is equal to 10. So what do we do with one-step equations? We simply subtract 10 from both sides. 5 from both sides in this case. So you subtract 5 from both sides. So now we're solving one-step equations. Two-step equations involve situations where you have to take 2 steps to get to the variable that you're looking for. And so in this case, we subtract 6 from both sides, and we get 2x is equal to 6, x is equal to 3. So that's the situation with two-step equations. Multi-step equations is the next level that you work with. What do we do with multi-step equations? If we have a situation like this, then we basically have to distribute that 2 in. We get 2x plus 12 is equal to 10. And then we subtract 12 from both sides. Notice that you're going to have a negative number here, so that's where your pre-algebra needs to be solid with understanding how negative 10 minus 12 would be negative 2. That is called integer arithmetic, and I can give you resources on that later if you need it. So then 2x is equal to negative 2. We divide both sides by 2. We get x is equal to negative 1. So first we distribute that in, then we subtract the 12, then we divide both sides by 2. That's just a general linear equation. Okay, let's move on to the next one. What about if the equation has fractions? What if it involves fractions? So you have 1 over 2x plus 1 over 4 is equal to 10. In a situation like this, I would recommend getting rid of the whole denominators and making sure that you now have a linear equation. So how do we do that? We multiply everything by the lowest common multiple or lowest common denominator, which is 4. So we multiply everything by 4, and we get the 2 goes into 4 2 times. So we get 2x plus, that just becomes a 1 is equal to 40. We subtract 1 from both sides. 2x is equal to 39. X is equal to 39 over 2. So we have 1, we have 9. And basically, the way I would recommend is just leaving it, instead of trying to make it into a mixed number, I would just leave it as x is equal to 39 over 2. And that's how we solve an equation involving fractions. What about equations involving formulas? Well, if it involves a formula, like somebody says E is equal to mc squared, and they tell you to solve that kind of equation, what you do is if you're solving for m, you divide both sides by c squared. So E over c squared is equal to m. We just solved for the variable m. Very good. Now we're going to move on to the next type of equation, which is an equation that is called an absolute value equation. An absolute value equation could be a situation like this. In this case, you have 2 solutions. You're going to have x plus 6 is equal to 12, and x plus 6 is equal to negative 12. So basically, you solve each one of them for x. You get x is equal to 6, and over here you get x is equal to negative 18. So negative 12 minus 6 will become negative 18. Very good. Now we move on to the next type of problems that come up with equations in algebra, and that has to do with variation. In algebra, you might hear about things like if something varies directly with something else, and if something is inversely varies with something else. So let's use a quick example from chemistry. If the pressure is constant, the volume of a gas is directly proportional to the temperature. And so variation is just showing you that if you take that variation symbol that I have over there and you put an equal sign, If you want to change that variation symbol to an equal sign, you have to introduce a constant of, we use the word constant of proportionality depending on the context of the lesson. So anyway, so you put that there, and now you've set that up for direct variation. There's also inverse variation. And what is inverse variation? Inverse variation is a situation where you have the pressure of a gas varies inversely to the volume of a gas. And this is actually called Boyle's law, and this is called Charles' law. And so P is equal to K over V. So K is equal to P times V. In this case, K is equal to V over T. So just something to keep in mind with variation and algebra. Very good. In algebra, you also hear about applications of distance, rate, and time, or the questions of age. If John is 5 years older than his brother, who is 6 years older than Peter, how old is John? My answer to that question is just ask John his age. Who really cares? And who sits around asking people how old is John if he's 5 years older than Peter? If your friends are doing that to find out other people's age, you might need new friends. No, I'm kidding. That's fine. But that is the type of problem in algebra that I think we need to eliminate. So let's move on. I'm kidding. I just find it weird that we never hear that in real life. Okay, now we use word problems in algebra. I just want to take a quick commercial break. We use word problems in algebra to try and bring the concept to life, to help people understand how we set up these equations and how they work, okay? We've spent the first 6 minutes, or 5 to 6 minutes, going over different kinds of equations. That's a lot of what algebra is about. If your understanding of equations is solid, then you can then proceed into graphing. Graphing is where we talk about things like, if I have a coordinate plane here, which is called the Cartesian plane, named after René Descartes, the French mathematician, then over here, y is equal to mx plus b is called the slope-intercept form of a graph. What does that mean? That means that a graph has this point where a line intersects, and that is called the y-intercept. It's called the y-intercept because at that point, x is 0. So that's called the y-intercept. The slope of a graph is like the speedometer. Your car, when you're driving, there's a rate of change, miles per hour, or if you're in other parts of the world, it's kilometers per hour. Notice that it's a rate of change. So if you're going 60 miles per hour and you travel for 1 hour, you would have traveled for 60 miles, right? There's a rate. So that's what graphing is about in algebra. So graphing deals with setting up these, linear functions. First of all, you learn in algebra, and they are built on knowledge of points. So basically, think of points like the address. When you tell someone, my house is 35th Avenue South and 13th Street, that's like you giving coordinates to a location. And that's what graphing is about in algebra. It's a big deal. It's in Algebra 1, Algebra 2, Geometry, Pre-Calculus, and Calculus. Graphing is everywhere. It's very important, and we discussed that in algebra. So there's 3 different ways to write an equation of a line. There's the slope-intercept form, which is what I wrote, the slope-intercept form. There's the point-slope form, and then there's also something called the standard form of the equation of a line. These are the 3 different ways of writing the equation of a line. I'm going to write them right here. Y is equal to mx plus b, y minus y1 is equal to m into x minus x1, and then the last one is ax plus by, right, is equal to c. That's one way we can write it if I want. So these are just general equations that you should be aware of as it relates to graphing. Very good. One more key item involving graphing before we move into the next realm involves this topic called parallel and perpendicular lines. So when you graph, you can have 2 lines that are parallel. That's very good. That means that their slope is the same. If M1 and M2 are the same, we say that the 2 lines are parallel. If M1 times M2 is equal to -1, if the slope of the first one times the slope of the second one is equal to -1, that means that those lines are perpendicular. That would mean that if I drew a third line and it formed an angle 90 degrees with one of these lines, it is perpendicular to the line. Okay, very good. Now we're going to move on to inequalities. So there's equations in algebra, there's graphing in algebra, and then there's inequalities in algebra. So what do we mean by inequalities? Inequalities would be situations like this. 2x is less than 6. So basically you solve the inequalities in a similar way that you solve equations. You divide both sides by 2, x is less than 3. But what about if it's -2x is greater than or equal to 6? You divide both sides by -2, and here's where the key difference occurs. we have to change this to less than or equal to, because we've divided by a negative number. So because we do that, we get x is less than or equal to -3. There's definitely more details to this, but right now we're just doing our 15-minute cruise through algebra. So we have basic inequalities that we solve, we have absolute value inequalities that we solve, and we have compound inequalities that we solve. When we solve an inequality, some people use circles and some people use brackets and parentheses. In this case, where x is less than or equal to -3, you go to -3, and x is less than or equal to, so you do a bracket, or you do a closed circle, and you go in that direction. That would be the answer to that problem. Very good. That's how inequalities work. In general principle, when you're solving inequalities, you're using a lot of the principles of one-step equations and two-step equations, and the general principle that you learn for dealing with equations. So keep that in mind and you will be just fine. Okay, next thing we learn in algebra is systems of equations. So we've done graphing, we've done inequalities, and now we're going to do system of equations. When it comes to system of equations, what you're doing is you have multiple variables and multiple equations, and you're trying to find what those variables are. So there's multiple ways to do this, and so we're talking about systems of equations. So what are these systems of equations? Well, we need to know that if x plus y is equal to 12, for example, and 2x plus 6y is equal to 19, then we have to use either substitution or elimination or graphing. If we're using graphing, we just have to graph these two lines and see where they intersect. Where they intersect is the solution to the equations of the line. So that's how we solve systems of equations. We use substitution, whereby we can say y is equal to 12 minus x, for example, and we take that 12 minus x and we plug it in for y in the second equation. That's substitution. Elimination is where you make sure that you have the same coefficient in front of things. So let me do a quick example. 3x plus 4y is equal to 12. 3x minus 8y is equal to 16. I just made this problem up, and then we subtract. Notice that you can eliminate the x's in this problem. That's how the system of equations works for this specific type of problem. Okay, so now we've gone through equations, graphing, inequalities, systems of equations, and we're going to turn our attention to polynomials. However, as you can see, the board is full, so we're going to take a break, and we're going to pick it up from here in the second part as we finish off the brief overview of Algebra 1.